Hello, welcome to the video for lesson 10-9. Yes, I know it says 11-9 at the top of the page. Just like the last couple of lessons, that's a typo. This is the last lesson for topic 10. It begins on page 52 in your notes packet. Word and step problems. Okay, so the learning targets. I can solve word problems with functions, graph real-world problems. So we're going to be solving and graphing word problems and real-world problems. That's what this is all about. All right, so we've got our very first one right away. Miss Kula bought a Fitbit 30 days ago to monitor the number of steps she walks each day. She has been increasing the number of steps at a steady rate. Based on her daily totals, her steps, S of D, can be modeled by the function S of D equals 200D plus 2,500, or 2,500, where D is the number of days since she bought the Fitbit. What does the y-intercept represent in the context of the problem? Now, you really have to get good at answering these problems, because remember, on the Regents, they love to ask, what does it mean in the context of the problem? All right, so the y-intercept is the 2,500. And the 2,500 is, the 2,500 is the number of steps. Number of steps for what? The number of steps Miss Kula took on the first day. Number of steps Miss Kula took on the first day, or the day she bought the Fitbit. Actually, it's more like day 0. What does the rate of change represent in the context of the problem? So, the rate of change is this 200, the slope. It's 200 steps per day, which is not really a lot, so obviously this is a fictional problem. It's the rate, it's her rate of steps per day. Or you might want to say, each day she walks 200 steps. Okay. Now, how many days did it take Miss Kula to reach 6,700 steps? So we got to plug this number into our function. I'm going to plug it in for S of D. So it's 6,700 equals 200D plus 2,500, or 2,500. So simple solving here. Subtract the 2,500 from both sides. And you get 4,200, or 4,200 equals 200D. Now divide both sides by 200. And you get a final answer of 21 equals D. What does that mean? Well, we're answering a word problem. It took her 21 days, or it took Miss Kula 21 days to reach 6,700 steps. Dun, dun, dun. All right, so that's page 52. Let's go ahead and take a look at page 53. I'm going to clear the screen, so if you need to copy it down, pause it. Page 53. In 1972, you could buy a Mercury Comet for about $3,200. Cars can depreciate in value pretty quickly, but a 1972 Comet in pristine, that means excellent, condition may be worth a lot of money to a collector today. In other words, the value goes back up. Let the value of one of these comets be modeled by the quadratic function v of t equals 18.75 t squared minus 450t plus 3,200, where t is the number of years since 1972. Now, before we fill in this part here, I've plugged in the values in my calculator, and I was able to, actually, let's answer the first question. Let me move the screen a little bit more. When is the value of the function equal to 0? And the answer is never. And the reason why? Because there are no real roots. No real roots, or in parentheses, zeros. Again, we still haven't really answered why, and here's the reason. The car will always be worth something. Always, in all caps, be worth something. It is not going to be worth 0 or negative dollars. It's always going to be worth something. So it can't be 0. Now, let's come down here, and I'm actually going to do a table. And I have t and v of t, or x and y if you want. T, now if you notice in our graph, I know they're going every other space, but they're going up by 4s. So I'm going to go up by 4s, all the way up to 28, and I want you to do the same thing. And then I'm going to fill in the values from the table in the calculator. So it starts at 0 years in 1972, it's 3,200. After 4 years, it's only worth 1,700. 8 years, $800, then 500, then it starts to go back up, 800, another 17. So I want you to fill this out all the way up to 28. And then we're going to graph it. So, there, in 1976 it was 1,700, in 1980 it was 800, and 84 was the lowest value, 500. Then it starts to go back up. 92. And then here. Now, the reason why we're graphing this is so you can see that your graph needs to be a parabola. And I know my parabola is not a perfect one, with an arrow only going here. It's not going to go here because, remember, we can't have negative number of years, so this can't go backwards in time. Don't forget to label it. V of t equals 18.75 t squared minus 450 t plus 3,200, and I know it's probably off of your screen, but you should be able to copy all that down. What was the car's lowest value? $500. Easy. You can look at the table or look at the vertex. What is the value in 2010? Now this you would need the table for in your calculator, or maybe you can plug in how many years that is, which is 38 years. And if you plug 38 in for t, you'll find that the answer is $13,175. So it's worth much more than it was originally. And then the last one, what year would the Mercury be worth $24,800? Either look it in the table or plug this in for V of t, and that's going to be at 48 years, which is 2020. Hasn't happened yet. Alright? Okay, one more problem we're going to do on our own over on page 54. Excuse me, do together, not on our own. Step function graphs. Piecewise functions are used to describe a wide variety of data sets. One good example of piecewise functions is income tax. The 2015 federal tax schedule for a single person filing is, and you'll see we've got these different rates and categories. So, this is how we graph it. 10%, so over here's the, oh by the way, the income is in thousands of dollars. So when it says 20, that's 20,000. So how about times 1,000? So $20,000. So at 10%, goes from $0 to $9,225. So here the tax rate 10%. So it goes from 0, so I'm going to shade in that circle, up to 9,000, which is just below 10. So open circle here, connect it. 15% goes from, so right here, so I'm going to shade in this circle. It's basically the same as this open circle here, all the way up to 37,000, which is a little bit below 40. So right here, open circle. 20% goes from this number, so I'm going to shade it in. I'll go right directly above it, shade it in, up to $90,000, or just over 90,000, but I'll stop at 90, which is here, and that's going to be an open circle. And then 28%, so I got to be a little bit below 30. It's going to start here and stop at 189,000, so about 190,000. Right about here. Open circle, connect it with a nice straight line. Alright, now it gets really interesting when we get near the end. 33%, so a little bit below 35, about halfway in between here. Shaded circle here, all the way up to 411, so that's the, almost 400, or a little more than 410,000. Open circle. Now, I really wish we could zoom this in because the next two get pretty interesting. So the next one goes from $411,501 to $413. It's going to be hard to show that. That's 35%. So it's right on the line. So shaded circle right here. And it's only going to go a little bit, and then it's going to be an open circle. And then the last one, 39.6%, starts where this one is, so a shaded circle at almost 40, and then I'm just going to put an arrow going to the right because that's everything that's above. So here is a piecewise. Notice they're not connected, but they basically, where one stops, the next one picks up. Okay? So, Mrs. Single's taxable income is $42,000. What is Mrs. Single's tax rate? That's pretty easy. You can look at the table to answer that. That's 20%. And then the one below that, Mr. Bachelor's taxable income is $189,000. What is Mr. Bachelor's tax rate? 28%. All right? So there are a few more problems that come after this you're going to answer on your own. If you had any trouble, rewatch the video or come see me for help. Good luck, and we'll see you in math.